Hey guys. Oh yes. So sorry, I think I was muted for a second for a bit. Yeah, so welcome once again to another session. This is part of our workshop live, you know, coding session that we normally go through tools and also things that you need to know about in the Axelar ecosystem. And then today we'll be talking about tracking and troubleshooting with Axelarjs and Axelarscan. Don't worry if you are hearing Axelarscan for the first time, or this is also your first time hearing Axelarjs. It's all good. We are going to go through the entire presentation together, and then we get to the demo part where we do everything hands-on and then go through all of these things that we have via our SDK and also using the Axelarscan platform. So moving on, my name is Idris Olubisi. I am a developer advocate at Interrupts Lab, and then I am a developer advocate at Interrupts Lab working on the Axelar network. And you can find me on all social media platforms at Olanesoft. So what are we going to be doing today? And then what are the things you would learn and make the most out of this workshop today? First, we talk about the Axelar general message passing. And also we also talk about the Axelarscan, both the mainnet and also the testnet. We talk about GMP transaction status and recovery. What do you need to do to recover transaction? How do you track transaction status? What are some of the things you should be aware of when you are building your application, your decentralized application? And also you want to give feedback to your users as transaction move from one chain to the other, confirming every step that the user needs to be aware of or like track or know about during the process of this transaction. And then we talk about the Axelar Query API, some of the functions available to you. Either you want to do gas estimate, you want to get transfer fee, or you want to get assets by denom. All of these things we are going to go through and cover everything during this shop. And then finally, we move on to the demo part where we'll be doing some hands-on with the Axelarjs SDK. Practically, we go through the step-by-step of what you need to install, how you should install it, and how you should set up your environment for development. Yeah, that's pretty much it. Let's get right into it. So, but before we start, I wanted to like reflect on some things, right? We are in a world where everyone is quite busy. Either you're busy on chain or you're busy off chain. And then the last thing any user on chain wants to deal with is a stock transaction. Don't worry, I've experienced such before, and it was really difficult for me to navigate through. And but yes, it's difficult. You heard that correctly. I want to send an asset across different chain, or within the same chain without having to deal with any delays. And if for any reason it gets stuck, like my concern was, how do I unblock this transaction myself without having any problem or without having to deal with different things at the same time? For example, I tried to send some assets, like think about asset like USDC or any other asset from one chain to the other. So in my example, I tried to send from Ethereum to, let's say, my friend on other networks like Base, Avalanche, Polygon, or any other blockchain. That is meant to be simple, right? Yes, exactly what I also thought at the time. But the transaction got stuck, and I had no idea why and also how to fix it. And then my friend was waiting, for the assets on his own hand. I felt helpless at the time. I started asking my question, what do I need to do to unstuck this transaction? What are the steps, or what are the things I even need to know under the hood that can allow me to, make this transaction go through? This should be dead simple, right? Especially because my friend is really in urgent need of that particular asset. So that's one of the things you can get done in seconds with Axelarjs or using the Axelarscan portal. And if you will, and it will allow you go from feeling like lost, just like the way I was feeling helpless, into the multi-chain maze where you confidently navigate through all of these things with ease. So today I'm going to show you how exactly you can do these things easily. And then by the end of this workshop, you have the tools to send messages across different chains effortlessly and also track every step of your transaction and solve any hiccups along the way in case you encounter any. So let's get started. So first thing first, I want to tell you about the Axelar general message passing. If this is your first time hearing about general message passing. So one of the Axelar general message passing is a feature that allow you to send messages across different chains. And then one of the most important feature that is available to you, like two of them, two functions that you can utilize out of the box, leveraging the Axelar GMP SDK, is the core contract and the core contract with token. Don't worry, I will explain what this means in a bit. So the first one is the core contract, right? So let's say you want to send message from chain A to chain B, and then you also want to interact with, you want to have like some custom functionality on chain B. That's after you receive this message, you want to also do like some custom functionality. An example here is, let's say I want to send like I want to send a bounty to a particular addresses, maybe like address of list of 10, right? And then I have the asset on one chain, and those users submit their address. What I want to do is to send assets from one chain and then disperse it directly into those other chains. So the custom functionality of disbursing those, the amount that is received on all the destination chain can be embedded into the underscore execute function that you have here. So to just keep this simple, right? Core contract allow you to send message from one chain to the other. So there are a few things you need to specify though, like the destination chain that you want to send to, the contract address, and then the payload. So payload in this case could be a string, an array, depending on what you want to like encode from the source chain to the destination chain. And then on the right hand side, you have the underscore execute function that runs automatically on the destination chain, which also takes in the source chain, the source address, and also the payload that was sent from the source chain. So any other activity, as you can see here, it's a function. So any other activity that you want to do custom functionality, you can plug that directly inside this function on the destination chain, and then it will get run automatically. So moving on, the second one is the core contract with token. So this simply allows you to send message, but now you're sending not just message, but you're also sending assets. So in this case, you want to send the message specifying the destination chain, the contract address, the payload. But notice two things here, the symbol and the amount, right? The amount you want to send, and then the symbol of the assets that you're trying to send. Let's say you want to send, for example, AUSDC, which is like or let me say USDC on mainnet, AUSDC on testnet, right? You want to send it from one chain to the other. You can just specify the amount that you want to send, and then add the symbol as AUSDC or USDC, depending on what the enum looks like. Enum is, which you can also find all of these details on our documentation. So to put things simple, right, this allow you to send a message across different chain, including assets. And the same thing also applies to what gets run automatically on the destination chain when you send a message. You have this function called underscore execute with token, and there's a source chain. You specify the source chain. You can retrieve the source chain, the source address, the payload that was sent from the source chain, and also things like the token symbol and then the amount. So additionally, if you want to include any other functionality or any other custom action that you want to happen on the destination chain, immediately the message arrives on the destination chain, then you can just embed it into this function. So to give you an overview of how the end-to-end flow looks like for Axelar general message passing, this is an example of somebody sending a message from Ethereum to Base, right? A dApp initiates that call and then calls call contract in this case, right? The call contract, this call goes through the gateway that is deployed for that particular network, and then it emits an event that is picked up by the Axelar network. And then after the network like the call, voting goes successfully and validation is completed, it goes directly to the gateway of the destination chain where approved contract call is being triggered to confirm that yes, this call has successfully been voted on and then approved. And now you can proceed to the next step. Then it goes back to the DAP on the receiving end, where the underscore execute method is called automatically, which is the receiving end that I mentioned. So I'll pause here a bit if we have any question before I proceed. All right, I think we are good for now. Oh yes, okay, the sound, yeah, the sound is good. Thank you for the feedback. So all right, moving on. Let's talk about Axelarscan, right? If you're in Axelarscan for the first time, it's a portal that allows you to visualize how message is being sent from one protocol to the other. So not just message, but also assets and so many other information like the validators, like the data that you need, how the number, all statistics, and also time that it takes for every transaction for different chains, right? To access Axelarscan on the mainnet, you can visit axelarscan.io. For testnet, you can visit testnet.axelarscan.io, right? So what we are going to do right now is to quickly visit the testnet portal. Yeah, so I just want to show you guys what it looks like. Right, this is the testnet, and then you can see informations like statistics. You can see informations like general message passing or token transfers. In fact, let me go to mainnet so you see like everything I'm talking about. Let's see like production environment, right? It's pretty much the same thing, but of course, one is mainnet and then one is testnet. You can also navigate from here if you want. So you can see cross-chain activities here. So I think this is clear, right? So now we have the Axelarscan where you can navigate to like statistics. You can check, GMP and also token transfers, like I mentioned. You can also check validator blocks, transactions, pool proposals as they are going on chain. What are some of the things happening? You can also check the resource tab for chains and assets. I'm waiting for this graph to load. After this graph is loaded, then we can see some other things that is available to us there, right? So now you can track information like transaction, the volume, the average volume per transaction, and the GMP contract call, and also some of these volume as they are moving from one chain, sorry, transaction as they are going from one chain to the other. But most importantly, as a developer, one of the interesting things that you are most concerned about is this GMP section that you can search for transaction. So this is an example of a transaction that was created 42 seconds ago, right, on mainnet. And then if I click on this transaction, it takes me to another page where I can find all the information that is required for that transaction. You can see in this example, we have somebody is trying to send an asset from Arbitrum to Binance, right? And then sending these assets. You can find information like where the transaction has been completed, sent here, the gas that was paid, their gas was paid successfully, and then waiting for finality at this point. After that, we go to approve and then finally execute, which means every step you can track it. So how do you want to track it, or how can you even track it? Let's scroll down a little bit. You can also see other details like sender, the source address, the contract, the recipient. So how do you track individual steps? So this is it. So at the confirm step, sorry, at the send step, you can click directly here to find information on that on chain, right? So let me go back to the portal. You can see the same thing here. So I will go back one step also to look for a transaction that have been completed. The one cool thing is that I can just go here and scroll. I can filter by anything, but in my case, I want to filter by status of executed, and then I can click submit. So I want you to bring me like all the transactions that have been executed up until now, so we can see the steps and also what are some of the background information that you might need on your own to know as a developer. So in case you are running a transaction and you're sending a message or asset from one chain to the other, and you want to know where the transaction is currently on, you can track that directly. Let me search this again. I'm not sure, but usually do not take longer. Okay, yeah, let me try testnet and see. So I can show you guys example before I go back to the presentation. Let's search for a transaction that is completed. Let me filter by another status and see what's happening. So we should be able to see. Oh, wait. Okay, yeah. Okay. So we should be able to see. Let's see. Let me filter by express executed. I just wanted to show you guys like what the information page looks like, just similar to this, but I'm trying to look for a transaction that was completely executed end to end. Yeah, so express execute. So now let's click on this, right? It's going to open up the new page where we find like additional information about that particular transaction. Yeah, as you can see here, there are different steps, right? This person is trying to send assets from Moonbase to Avalanche and sending AUSDC. So you can see this is testnet. This is the first step, which is sent, and then gas was paid, express executed, which is another step, and also confirmed, approved, and finally at the executed stage. So if you scroll down, you see at every point what happens on chain, and then you can click to confirm all of these things as they happen on chain, from the sent to gas paid to express executed. Every step can be tracked on chain, and you can also find like additional information on what exactly is happening. If you click on, let's say, let me click on the executed now, you can see it takes us to like Avalanche, this node trace explorer, and then we can find all the information that we need here, and like all the information you need or you need to confirm here based on what's happened on chain. So like this is really cool, and it also allows you to one thing I don't want to forget mentioning before I switch back to the presentation is, let's say you have a transaction. Let's say you have a transaction. Let me search for my own transaction. Yeah, let me copy my address and then search. I want to give you guys an example of a transaction, and then let's say you have a stock transaction, which is the point of this workshop, right? You have a stock transaction, and then you don't know what happened. Maybe it's gas payment or it's for another reason, and you want to directly fix it without bothering everybody, and also doing it seamlessly. I'm waiting for this. So I want to see. So once I get like all the information, then I can not sure why it's taking this long. Okay, yeah. So now I have this, right? You can see all my transactions. I'm going to navigate to a transaction that needs gas payment, right? Let's say page 9, to retrieve a transaction. So this is how you can track. I pasted my address so I can track things. You can see this transaction says what insufficient fees. I'm going to open that transaction. So let's know why. So why here is insufficient fee, right? And then you can see that I have a button for recovery, which is the first step I wanted everybody to know about, right? This is the first step of, yes, I have this recovery process, and what does it require me to do to add gas? And there's this button here that can make me add this gas directly. So if I click on add gas, it says adding gas, and I'll get a wallet pop-up that will just allow me to connect and add this gas successfully for this transaction to go through. So you see what will happen in a second. So it's currently adding the gas. Once it's completed, I should see if the transaction for this particular action of adding gas, right? You can see it's successful, right? If I click on it, I can view directly. This was done 24 seconds ago, right? And then we have the function that was called, which is add native gas. We're also going to do that in the practical session. So now this is like how to add gas, and I can refresh. If you refresh, you see that this transaction would go through. So you can see this transaction has now indicated gas paid, it has been confirmed, and now it's trying to approve. So this call will be approved, and then finally move on to execution chain. You can see how cool it is for me to just quickly, unblock a transaction and then make it just go through in seconds by just clicking a button and approving, and then I'm good to go. See, this is from a background of, yes, I want to do it directly on the UI. I don't know how to code, or I know how to code. I don't want to start doing anything programmatic because I want to get my transaction unblocked. You can just come here and then do it real quick. So now let's go back to the presentation, right? So you've seen how some of the things that you can do with Axelarscan, and then how easy it is for you to quickly navigate and then unblock any transaction yourself. Like, you can just do it right away, just like what we did right now. So now let's talk about GMP recovery, GMP transaction status, and also recovery. What are some of the options available to you apart from the one I just showed directly on the portal? What are some other options available to you out of the box, leveraging the Axelarjs SDK and some other toolings that we have? So first thing I want you to note about the GMP and how to recover or like query and recover GMP transactions. First, we have something called the Axelar GMP Recovery API, right? And this API powers different things. First, one of them is to query transaction status. A very good example here is you are trying to swap your assets from one chain to the other, and usually swap, there are so many routes to it, right? And then you probably there's like two-stop. You need to swap to something before something, and then finally give your asset on the destination chain. You want to track at each step what is happening and then what is going on under the hood. This is where querying transaction status comes in handy. Now, of course, so many other use cases, right? But most importantly, this is under the Axelar GMP, which is Axelar General Message Passing Recovery API. That's number one. This other one is also manual relay to destination chain. Let's say another example which you can do directly from the portal is, let's say your transaction is stuck at confirm step, just like we saw when I was showing the Axelarscan. If it's stuck at confirm step, then you might want to do a manual relay yourself. Maybe for any reason you want to try it on your own to manually relay that particular transaction to the destination chain. There's another API that is available to you directly out of the box, leveraging the SDK. And then the other one is executing transaction. Let's say your transaction gets stuck at the execute step, which is the final step on the destination chain. You can either go to the portal, or if you want to do it programmatically, let's say you have a very built application, you built your DApp, and then there's some sort of tracker that you just want to do all of these things automatically. You don't want your user to leave your app to start going to Axelarscan or to start trying to do it programmatically. So you can set up, like, if you have like any backend system set up, you can run like a cron activity to check if at any point in time there's any execution. But in most cases, right, the system is usually stable and all of this execution process happens automatically without having to manually relay them yourself. So that's for execution. And then finally, the add native gas. Under recovery, I just added native gas directly on the portal, but you can also call an API to add a native gas to a particular transaction. Once you have you can do that locally, programmatically, and then you can do it with ease, right? Just one single function call, and you'll be able to add a native gas for any stock transaction. So now, what does the query transaction status looks like? So it's a very simple function, and calling the function on our SDK called query transaction status, right? And then you specify the transaction hash. So in this example, I'm specifying and then logging the status, right? And you get a response about like an object that contains a lot of information about your transaction and also the current status of your transaction. Don't worry, in the demo session, I will demo how you can get a transaction status. Like, we'll see all of these things in action. So moving on to the next one is the manual relay to destination chain that I mentioned, that if at any point in time your transaction is stuck on, let's say, confirm step or approve step, and you want to manually relay the transaction, you can just simply, specify the source transaction hash, get the transaction hash, set a provider, and then after you have that, you specify your private key, which is usually the case for local setup. And then you call the function called manual relay to destination chain. So this function allows you to manually relay that particular, transaction, specifying the transaction source, the source transaction hash, and then the sender option. Excuse me. Yeah, so after you specify that, you can now just call this function and it happens on the network itself to relay that particular transaction to destination chain. All right, so moving on, the next one is adding native gas, right? So if you also want to add native gas, just like we did when I was trying to add directly on the Axelarscan, and you want to do it programmatically, what you just need to do is to import the GMP recovery API, the gas, the environment, and the add gas option, and then get the Axelar GMP recovery API and specify the environment, if it's testnet or mainnet. And then there's this callback. After we call this add native gas, there are things that gets returned to you, the sources that you can track. If it's successful, then you can add any action, get the transaction details itself, and if there's any error, also log it in your application. So you just need to specify. So in this example, I'm specifying avalanche, right? And then I'm specifying the transaction hash. I'm specifying the estimate gas use. This is usually like the gas limit that you need to estimate there, and then some other information that might be useful to you. You can find all of these details on our documentation. Right. So this is the last part of the GMP recovery API. And then we now have manual executing a transaction. The one we did earlier, like one we talked about earlier on, is there are different things that you might want to do, but particularly for this manually execute a transaction, you're going to call the execute function directly on the SDK. They're similar, the way you set them all is kind of similar, but the functions are just different, right? And then you go call this function on the SDK, execute, specify the source transaction hash, and then specify the sender options. And that's all you need. Call this function and you're good to go in your application. So now let's talk about the Axelar query API. But feel free to drop your questions. If you have any questions at all, I'll be happy to answer them. I'm seeing all of the comments from X, from YouTube. I'm with you guys. If you have any questions, feel free to drop. And if you're not so sure, if you have like clarification during the demo, we'll go through all of these things together. So now let's talk about that. The first one we talk about is the GMP recovery, but that's not all Axelarjs or Axelarjs offers. It's way more. We also have the Axelar query API, right? So what exactly is the Axelar query API? It's also an API that have like other methods that are available to any developer to utilize. One of the methods is estimating gas fee. You see, one of the most important thing in dealing with like on-chain transaction, you don't want to overspend and you want to be sure that yes, you have the value for money. Right. So if, for example, if you want to send, let's say from Ethereum to Avalanche or Ethereum to Base, and then you want to send an asset across, you want to send an asset from Ethereum to Base, right? It's easier for you to just add code any value as the gas fee that needs to be paid. So under the hood, what Axelar is doing, we have something called the gas service that help you manage your gas. Because ideally, if you want to send from, let's say, Ethereum to Base, because Axelar is a proof of stake network itself, so that means ideally you are interacting with like 3 blockchains, because you're interacting with Ethereum, Axelar, and then Base. You're supposed to pay like 3 gas. But Axelar makes it easy that you can just pay gas once, and then you don't need to pay on Axelar. You don't need to pay on the destination chain, any destination chain that you are sending the assets to. But once you pay the gas once, the everything gets taken care of, right? So one of the things you don't also want to do is to overpay or just put random value. So we've also provided an SDK that can allow you to estimate a particular amount and then what it costs to send a transaction from chain A to chain B. So if it costs so great, you are going to get that value and you'll be able to send that amount alongside your transaction, which is going to give you a proper estimation of your gas. But another thing to note is even though you overpay, we do this so that you reduce like overpaying and all of that. But even though you overpay, we also have a refund mechanism that refund you the remaining gas after you initiated the call. But if you use the estimate gas fee API SDK, like on the SDK, you are going to be rest assured that yes, the amount that is going to be deducted, or like the amount you need to pay, would be like the amount required for the transaction to go through and nothing more. And another function here is getting transfer fee. Let's say you want to transfer from one protocol. Apart from GMP, we also support like asset transfer. So if you want to transfer from one protocol to the other, you can also get the transfer fee directly by calling the get transfer fee on the SDK. Another one here, as you can see on the screen, is the getting denom from symbol. Let's say you're building an application and user are selecting like different assets, and you want to know which assets they are selecting, and for that asset, what's the denom, what's the symbol. So what's the denom on chain, what is being registered as, and then what's the symbol. So let's say a symbol is provided, you can use that symbol to get the denom. There's a function to do that. Another one is if a denom is provided, you can use the denom to get the symbol for that particular asset. So now let's talk about them individually. The first one is the estimate gas fee. So this is how you can estimate gas fee and then the expected parameters that you need to pass in when you are making this call. Passing your source chain, your destination chain, if you want, let's say Ethereum to base, Ethereum to base, or and then you specify your gas limit, you specify the gas multiplier. You can keep it at, by default, it's auto, but you can also put any multiplier that you think will be valuable. So even though you don't pass in, it's going to be set as auto. You can pass this, you need to pass the source chain token symbol, and then minimum gas price is default to 0. If you have any data that you want to pass along, and also the GMP parameters that is required for this transaction, you can pass it in, and then you add like your function implementation there to call this estimate gas. So this is the function that you're actually calling on the API, and then you can pass in the parameters. So this would also return a value in way to you, so you can convert it to whatever you want to use it, or like just pass it directly along to any function call that requires you to pay gas on chain. Yeah, so moving on to the second one is the get denom from symbol. Like I mentioned, that you can get denom from symbol or like get symbol from denom. So you just create a function here, and then these are the things you need to specify: the API using the Axelar query API, specify the environment. In this example, testnet, it could be testnet or mainnet, and then call the get denom from symbol, passing these two parameters. So what we want to get here is the denom for this particular asset on Moonbeam, right? So we pass in AUSDC, and then we pass in the network, right? And then we log it. So the expected result here is UAUSDC. Strange. UAUSDC, right? And then you get the value in denom. You get the value log here. That's the denom for this particular asset on Moonbeam. So the next one is getting transfer fee. You can call this get transfer fee directly from your application, right? And then you specify destination chain name, the source chain name, destination chain name, the asset symbol, the asset denom, and then the amount in denom, right? Specifying all this information, you'll be able to get the transfer fee. So now let's move on to like getting symbols from denom, which is similar to like getting denom from symbol, but different function. In this case, we are calling get symbol from denom. So we now pass in denom, passing the network, and then it returns this symbol for us. So you might be wondering, like, where do I need to use it? There are so many use cases around this, especially if you have like custom implementation and you have a backend that you're implementing so many things under the hood. Then all of these things will come in handy and then very useful to you in your application. All right, so now let's get to the demo session. Yeah, what we are going to do is very simple, right? We are going to write a script to test like GMP status recovery, to test handling native gas, and also doing some sort of gas estimation example. Yeah, so let me all right, let me exit and then just move back to my application. So I already have this directory created. So let me zoom in just to be sure you guys can see my screen. What's going on here? Okay. Let me bring it down like this. Okay. Yeah. So I believe you guys can see my screen right now. I'm already in this directory. What I want to do is simple, is just to set up my environment so that we can test this. I already created this directory called Axelarjs demo, right? Feel free to name it anything you want, but the first thing I want to do is to initialize npm there so that we can begin our setup. And then I've initialized npm. And the next thing I want to do is to install a few packages, right? And one of them is the Axelarjs network. Let me clear this up. So I'm doing this, but I'm going to put like data v5 just to have like the v5 version. So I'm installing the Axelarjs SDK. I'm installing ETAs, and then I'm installing .m so I can be able to retrieve my environment variables, right? And then click on install. Wait for this to complete, and then we set up our private key in our env variable. Ignore this. I'll just change this right away. So I just need to switch my version to the 18. Yeah, so clear. So now the next step for us is to, you can see we have this installed, to set up private key. So if you don't have private key set up, please just set up if you're following along. And then next thing we want to do is to create a new file. So let me zoom in again to be sure you guys can see my screen. Wait, why is my zoom not working? Oh my God. Just give me a second. Okay, yeah, I think this should be clear now. So now I will just quickly create a file called index.js, and then I'll close this up right now. So index.js, what is the first thing we want to do is to import like the packages that we just installed, and then we'll import our package, the Axelarjs SDK, and also the ETAs, then the .env that we also installed, right? So now we have this imported. The next thing we want to do is to import our private key, like just read our private key and save it into a variable that we can reuse later on in this session. So let me scroll down a bit. Yeah. So now we have this, we have what we need, but the first thing we want to do is to initialize our SDK, because this is the SDK that we'll be using. But since we want to start with like getting transaction status. So the SDK that we need here is the GMP recovery SDK and then the query API. So we'll be using GMP recovery API first, but let's just go ahead and initialize both here, pending the time that we'll start using them. You can see I called one recover SDK, and then I'm initializing this from the GMP recovery API, and then the other one Axelar query API, because they are two different things according to what I explained during the presentation. And now that we have this, so what's the first thing we want to do is to get transaction status. Let's test out you can get transaction status directly from any transaction. So I'm going to write a very simple function to do this to us, right? To do this for us, right? Function to get transaction status, right? So it's quite simple and straightforward, but I'll just like follow a standard. So in case we run into any error, we can fix that immediately. So this is a simple function to test how you can retrieve a transaction status for any transaction by specifying it. So to run this is quite straightforward. But I'm going to create a usable main method that will allow us to run like all actions. We just need to like comment them where necessary, right? So first thing we want to do is what we want to do next is to just call the function called get transaction status, and then pass in the transaction. But I don't have the transaction. Let me go and pick up a transaction that is currently ongoing, and then we can use that to test. So I'm going to head back to Axelarscan testnet, go to GMP. All right, yeah. So I have this transaction. Okay, this is this transaction. So I can just copy this transaction hash. But before then, let me rewrite this so that it's easier for us to reuse. So I can just comment this out and then say, okay, all right, yeah. So I can just since I want to like reuse and test all the functions, so we can have a simple method that can allow us to do that asynchronously. So I'm going to paste this transaction hash now that I just got from this thing. So we want to see the status of the transaction. Don't forget, like this one that we copied, transaction that is going from optimism Sepolia to Avalanche, right? So now I can go back here since I have the transaction, and then I can call the transaction as. The next thing I want to do is to run this application, run this script rather, index.js, right? So it's getting the transaction status. So if you can, as you can see on my, my terminal, I have like the transaction information. But then one important thing is the transaction status object, right? You can see that the status says what sourceway gateway called. It can give you the exact step that we are. So let's open it up and see the exact step. You can see that it says waiting for finality because at this point the source gateway has been called, right? So this is the last status, at least for the transaction, right? And then you can find other information about other, maybe the gas paid, the method, the status for gas payments. You already changed to like gas paid already, so it has moved past, this stage. You can find other relevant information that you might want to display to your users. You can also find transaction, the call transaction for the source chain. This was triggered from Optimism. So in case you want to track anything or show anything on your UI, you can just get the chain information directly from here on what was triggered and how what are some of the things that you can do. In fact, it comes with like the event, what happened, like what was the event. The event here is contract call, as you can see on Axelarscan here. Call contract here. So right. So now you have like contract call, event log. We have some other information about the destination chain, the chain type, and some other things relevant that you can find really useful when you are building your application. Right. So this is how easy for you to get a transaction status. So the next thing we want to do is how you can manually relay a transaction. But I'm going to just show you what the method looks like and then proceed with the next steps. All right. So now we have successfully implemented how you can get a transaction status. So the next thing we want to do is to write a function that manually recover a transaction for us. So for manual recovery or manual relay rather, if you want to relay a transaction that gets stuck, maybe from at any step, right? And then you want to manually relay it on the destination chain, you can just call this function called manual relay to destination chain. And then you pass in the transaction hash, the sender options, and some other information, right? You pass in some other information. So to manually relay, or it's also quite simple and straightforward. We just need to update our script that we are running, for this. But in this case, what I'm going to do, I'm going to comment this out. So if you want to run this script, this is what you need to send. So an example is passing our private key, and also the RPC provider I'm using here is Phantom. This is an example of me trying to manually relay a transaction on Phantom. And then I can await manually passing the transaction hash, which is this one and this. But because this transaction is not a step that we want to manually relay, I just want to showcase like you guys see how to manually relay before we move on to the next step. So you can pick up any transaction that require manual relaying, or you want to do that custom functionality yourself. All right, so the next step we are going right now is to test how you can add native gas. If you don't forget like our steps from the presentation, like adding native gas, right, is the next step. So if you want to add native gas, it's pretty similar. Let me just take this up a bit. So it's really similar to how we did other functions, but the only thing is that we are utilizing the recovery SDK in this step, and then we are going to just write a function that manually add native gas. So there's so many logs here. This is just for clarity to see everything that happens on chain. And then one of them is, you can see like the estimation here. I'm calling the recovery SDK, and I'm calling this method called add native gas. And then specifying the chain, the transaction as the gas estimated and option. And then remember the callback here, which is like the return object. Success, we tracking it and then log the transaction hash. If not, we log the error and then we test this function. So for us to test this add native, which is the step 3, we are going to specify we need some information to be specified. Information like the chain, information like the provider, and also the option, like the option which includes like our EVM wallet details, private key, and also provider. So I'll go back to this block here and then click enter. Those are the previous one we did. So you can see I'm specifying the chain here. And in this example, I want to use Phantom. The gas used here, which is the gas limit. And then the RPC, I have the amount that I want to add, and then the refund address. So this is another cool thing. In case you had a native gas, and then at the end of the whole transaction, you have like some leftover, like gas remaining. Any address that you specify here, it will be like the remaining gas will be refunded to that particular address, which is another cool thing I mentioned during the presentation, right? And then we specify this, we specify like private key and also the provider. Then now we can call the method itself, which is the add native gas. I'm passing all of these parameters. So what do we need to update now? We need to update this transaction as, because remember that this transaction that we copied here is not a transaction that requires gas has already been paid. Let me see. Gas has already been paid. So what I'm going to do is I'm going to look for a transaction that requires gas payments. I'm going to check my wallet again because I have like quite a few pending transactions that I can test with here. So let's do so let's go for this that says Phantom to Avalanche insufficient fund. And you can see, it said insufficient fee that I need to pay. I can pay directly here, but what I'm going to do, I'm going to copy this transaction hash, go back to our code, and then replace it there, right? Because this is where you want to pay the gas for. And then we'll go back to our terminal and test that out. Clear. And then now I'm going to test again. So it says adding native gas for this transaction, right? You see the magic, right? Just wait a second. So it said added native gas. So now let's check if it is true. You come back here, you can see it changes automatically. It's now showing confirm, even though you are not supposed to click this confirm because it will do that automatically by itself, right? You can see, but it's no longer showing what insufficient error or insufficient fee rather. So if I refresh, you can see like that's the next step that we have right now. So this is going to automatically confirm and then move to approve and move to execute. So that's how you unblock a transaction that needs more gas to be added, right? And then I just call that directly with this single function call here that we implemented in our function, which is called add native gas. And then I pass it in, and then I added the value easily. So now this is the step 3. So now let's go to the last step here, which is part of our demo, to do gas estimation. So I'm going to go back here. Let me minimize all this function, make it cleaner a little bit. So now we have that. So now I'm just going to like create more space here. And the next thing I want to do is to do gas estimation. Let's say I want to send from Base to Avalanche or any other chain, or Ethereum to Base, for example. And I need to know the estimated amount of gas that is required for me to make that transaction go through. So all I need to do is to create a function that can do that for me, and then call this estimate gas fee on the Axelar network, on the Axelarjs SDK, and I should be able to do that. So to do this, we can just create this function here, and then we pass in the source chain, we pass in the destination chain, the gas limit, the gas multiplier. I'm setting it to auto here, so I want the system to pick it up by default. And then Now I'm calling the estimate gas fee. You can see what another difference here is that I'm calling query SDK, right? Which is different from the GMP recovery SDK, right? And I'm specifying the source chain, destination chain, the limit, and the multiplier. And then I'm logging the fee. So now let's go to the block that we want to test this out. So in that block, now we can just add the method to test it, right? So we can call, let's say, yeah, await. We can just await estimate gas fee. Yeah, so this is already pre-filled for us, but the transaction we can test with anything, right? So I'm going to test with this and this, right? And then I'm passing the limit, which are the inputs that we specified here. Let me scroll up right here. Like the gas multiplier is already auto, so you don't need to. I've already specified that. And then now I can go back to my transaction and then test it to my terminal and test again. So it said estimating gas fee, and then it says invalid chain identifier. That do I mean Ethereum underscore Sequoia? So which is great because they are always chain name for different chains, right? So let me show you what I mean. Let's go back to docs.axelar.testnet, right? This has for testnet, chain names, right? So if you keep scrolling, you see that we have chain name, we have gateway, and then we have chain ID, and we have gas service contract, right? So for this chain, it is case sensitive, right? So this is Avalanche, you can see here, and then this is Binance. So anytime that you are dealing with like specifying chain name and you're trying to send message from one protocol to another, one chain to another, you need to make sure that the chain name is correct so you don't run into an error. But if you're using just the SDK directly, you can see that it prompted us that yes, do we mean this particular um, chain name, right? So if you scroll down, you see that there's nothing like Ethereum. It's Ethereum Sequoia, right? Which is the recommendation that the JSSDK recommended. So now let's go back to our code and then just specify instead of Ethereum here, I'll replace with Ethereum Sequoia. And then for Phantom, we can also confirm yes, it's Phantom. You can see it's Phantom, right? And then now I can go back to here and clean up and then run this. It says estimating gas fee for this, and then the estimated gas fee is what? 8. So this is in way, right? So let me do something real quick and then go back to let's try to use it. I think it's converter or something. Yeah. So you can see what the value looks like in way, right? So for that transaction, for that estimation, you can see the ether that is required, right? I paste in the value here, and then this is what is required for the transaction, right, to go through. And another cool thing that you also need to know is that in case you overpay, so the point of using the estimate gas fee function is for you not to overpay. But should in case you are not using this, or in case you overpay, you had coded it somehow, and at the end of the transaction there's a leftover, it will be funded directly to address that is specified in that core contract or core contract with token call, where you can get the remaining assets back into your account. So that's pretty much what I want to show you guys in the demo part of this talk, where of this workshop, where we go through like writing script for GMP status, recovery, adding native gas. So moving on with the presentation before we wrap it up. If you have any question, let me check if there's any question. If you have any question, I know you have like questions later on, even if you don't now. Feel free to reach out to us. And also, let me wait for a sec. Let's see if there's any question, clarification before we proceed. All right, there are no questions. So there isn't any clarification yet. So, but then we support you, right? Anything you are doing, we want to make sure that you are successful, because all of these implementation are things that we've written like code samples and also experimented. So instead of you going through like the stress of doing the whole thing again and again and again, we have like different ways to support you. One of them is the Axelar support repo. Okay, yes, thank you, thank you. I can see comments from in the comment section. Thank you for the feedback. Yeah, so Axelar support is one of our support flow. We have our Discord, but this support we get notification instantly. In case you have any issues, question, clarification, please feel free to open an issue here, and then we'll be happy to answer all your questions. And then we also have Axelar example. This is a repository that we've prepared for all builders. It contains a lot of examples from Cosmos to SUI examples to EVM examples, and then you can test directly locally. In fact, you don't have to deal with faucet or anything at any point in time. You can test directly from your local environment, set up your local environment, and you should be good to go. All right, so one last thing before I end the stream, like this is a QR code I want you to scan, and please tell me what you think about this session, how this session have been able to help you. It takes literally less than 1 minute to fill in this survey. It's not going to take your time, trust me, but I'll be happy to hear back from you guys. If you find this workshop helpful, what are some of the feedback? What do you think we should do better? I'm happy to get all of those feedback in and improve on in the next workshop series. So thank you so much once again for joining. I'll wait for 10 seconds. If there are no questions, then we can call it a day. 10, 9, 8, 7, 6, 5. I don't know if I'm too fast, but yeah. Thank you guys for joining. I really appreciate your time. See you in the next one. Bye.